This video is brought to you by dreamsmadeeasy.wordpress.com. Log on to dreamsmadeeasy.wordpress.com and find free mock tests, solutions, and tutorials. Check the links in the description for more such helpful topics. Also, please don't forget to subscribe to our channel. Enjoy watching the video. Hello and welcome. In this video, I have compiled some questions from the previous years that were asked in the AIPMT exams. So these questions related to the first chapter of chemistry, that is the basic concepts of chemistry. I have solved some of the questions for you and have left some of them for you. If you face difficulty in solving these questions, please let me know by writing in the comments sections. Also, please write down the answers of these questions in the comment section below. Check for some helpful links in the description below. Here is a question that was asked in AIPMT 2009. So what is the OH minus in the final solution prepared by mixing 20.0 ml of 0.050 m HCl with 30.0 ml of 0.10 MbAOH whole twice? Now this question is quite straightforward, but the reason I picked it up is that it is the presence of your mind. So be careful while you appear in your exam. So let's try and solve this problem. So we have a 0.05 m HCl solution. What it means is that 0.05 moles of HCl are present in 1 liter of HCl solution. So 20 ml of HCl solution will have 20 into 0.05, and I'm putting this 10 to the power minus 3. This is to make sure that we account for the milliliter. So the number of moles present here in this 20 ml of HCl solution are 1 into 10 to the power minus 3 moles of HCl. So 1 into 10 to the power minus 3 moles of HCl are present in 20.0 ml of 0.05 m HCl. Similarly, in the case of BaOH whole twice, we can write 30 into 0.1 into 10 to the power minus 3, which gives you 3 into 10 to the power minus 3 moles of BaOH whole twice. So we have 30 ml here and we have 0.10 MbAOH whole twice here. So now we know the number of moles of each of these present. But here is one thing that we need to observe. HCl is made up of H plus and Cl minus ions, and BaOH whole twice is made up of Ba2 plus and 2OH minus. But in the case of BaOH whole twice, 3 into 10 to the power minus 3 moles will have twice the amount of hydroxyl ions. Why? Because this 2 is present here. So we have 6 into 10 to the power minus 3 moles of OH minus. Now what it means is that 1 into 10 to the power minus 3 moles of H plus and 1 into 10 to the power minus 3 moles of OH minus will react together to form H2O, and 5 into 10 to the power minus 3 moles of OH minus will be left as residue. So OH minus left as residue is 6 minus 1 into 10 to the power minus 3 moles. But there is one thing to note here. 30.0 ml of 0.10 BaOH whole twice is added with 20.0 ml of 0.05 m HCl. So the volume of the solution here is 50 ml. So 5 into 10 to the power minus 3 moles of OH minus are now present in 50 ml of solution. And if we have to convert it into molarity, we have to find it out in 1000 ml, which is equal to 1 liter. So 5 into 10 to the power minus 3 moles is present in 15 milliliter, and therefore how much of it will be present in 1000 ml? This is a simple trick, and therefore our answer becomes 0.1 moles, and this is the molarity. So the answer is 0.10 m, which is the correct answer. Here is a question that was asked in AIPMT 2007. Let me read the question for you. Concentrated aqueous sulfuric acid is 98% H2SO4 by mass and has a density of 1.80 grams per milliliter. Volume of acid required to make 1 liter of 0.1 m H2SO4 is, and we have the four options: A 16.65 ml, B 22.20 ml, 5.55 ml, and D 11.10 ml. So let us see what is already given in this equation. We have the mass percent of the solution, which is 98%. The density is given, and that is 1.80 grams per milliliter. Now let us try and find out the molarity of the solution. So the molar mass of H2SO4 is, I don't think I need to explain very much about it, is 32 plus 64. So it comes out to be 98 grams. And therefore the molarity should be molarity of the solution. Let's try and find out that. So we have 98%, then 98 by 100 into the weight of the solution, which is 1.8 into 1000, because it's 1.8 grams per milliliter. So this amount of grams is present. So this is this much is the mass of this 1.8 into 1000 is the mass of 1 liter of solution, and the number of moles present in this 1 liter solution is, we get it by dividing it by 98. So it comes out to be how much? 98 cancel, 100 and 1000 cancel, giving out 10. It comes out to be 18 mole, or the molarity of the solution is 18 m. So it's quite simple. The molarity of the solution is 18 m. So let us first understand what is wanted in this question. So we have 0.1 m H2SO4, and we have the volume of the solution to be made is 1 liter. So we have to make 1 liter of 0.1 m H2SO4. So let us write the 0.1 m into 1. This is nothing but the, what is this? This is just writing that 0.1 moles. So 0.1 m H2SO4 means 0.1 moles of H2SO4 is present in a liter. So if we just multiply 1 liter with it, we have 0.1 moles. Now what we have to do, we have to find out that much amount of volume of the acid, or the 98% H2SO4 acid, which will be having 0.1 moles. So we know that the molarity is 18, and we need to find out the V2. So our V2 equals, if you calculate, it comes out to 0.1 by 18, and if we use in milliliters, we do it in milliliters. So this is in milliliters, it comes out to be 5.55 milliliters. So this is our answer. So in this type of problems, you have to mainly do two things. One, you have to find out the molarity of the solution. Second, you have to apply the formula M1V1 equals M2V2. M1V1 equals M2V2, which is nothing but the conservation of mass principle. Next, I have some questions for you which you should be able to solve now. So which of the following is dependent on temperature? Molality, molarity, mole fraction, and weight percentage. Question number 2. Suppose the elements X and Y combine to form two compounds XY2 and X3Y2. When 0.1 mole of XY2 weighs 10 gram and 0.05 mole X3Y2 weighs 9 gram, the atomic weights of X and Y are: option number 1 40, 30, option number B 60, 40, option number C 20, 30, and option D 30, 20. This question was asked in the year 2016 AIPMT Phase 2 exam. Here we have a question that was asked in the year 2015 in AIPMT. What is the pH of the resulting solution when equal volumes of 0.1 m NaOH and 0.01 m HCl are mixed? Now the options are given below. Now in this question, Let's assume that we have 1 liter of the solutions, 1 liter of NaOH and 1 liter of HCl. 1 liter NaOH has a concentration of 0.1 m and 1 liter HCl has a concentration of 0.01 m, which means that this NaOH has 0.1 moles in 1 liter, 0.1 moles of NaOH in 1 liter, and this one has 0.01 moles in 1 liter. So when we mix them, what happens is that the OH minus of NaOH and the H plus of HCl react together to become H2O. Now we have 0.01 mole of H plus only, and therefore it will react with 0.01 mole of OH minus. Now in this case, in the case of the NaOH solution, what we will have 0.1 minus 0.01 mole of OH minus left, that is 0.09 moles of OH minus will be left in the solution. Now there is one thing to note here very cleverly, means this is something that you have to note, or else you will get the sum wrong. Now when we mix 1 liter and 1 liter of NaOH and 1 liter of HCl, we have 2 liters, and that is something you have to understand. So in 2 liters of this solution, we have now 0.09 moles. So 0.09 moles are now present in 2 liters of the solution. Now if we calculate the molarity, it will become 0.09 by 2, which becomes 0.045. Now let's calculate the POH. POH is nothing but the negative of the logarithm to the base 10 of the OH minus. And this, remember, this third bracket means that this OH minus is in molarity, that is M, so capital M. So let's try to understand this. So log of OH minus, so we have to write down this log. Let's write it down here. So minus log base 10 of, what is the concentration here? It's 0.045. Now if we try to break it down, it becomes log of 4.5 into 10 to the power minus 2, and you can understand that what it will become is log base 10 4.5 plus log base 10 to the power minus 2, which means that the value will be somewhere between 1 and 2, and therefore our value of pH will become 14 minus 1 point something. So it will be around 12 point something, which is the solution here. The solution is C. Next we have question number 3. Following solutions are prepared by mixing different volumes of NaOH and HCl of different concentrations. A 60 ml m by 10 HCl plus 40 ml m by 10 NaOH, B 55 ml m by 10 HCl plus 45 ml m by 10 NaOH, C 75 ml m by 5 HCl plus 25 ml m by 5 NaOH, D 100 ml m by 10 HCl plus 100 ml m by 10 NaOH. Now pH of which one of them will be equal to 1? For this question you have to understand the meaning of pH. It is negative of the log of the concentration of hydrogen plus ions, which to the base 10. So a 0.1 m concentration of H plus ions will have a pH of minus log 0.1 base 10, that is 1. Similarly, a 0.01 m H plus solution of H plus ions will have a pH of 2. So this is the concept that you need to understand in order to do this sum. So another question for you. This has been asked twice in AIPMT 2015 and 17. So what is the mole fraction of the solute in a 1.00 m aqueous solution? So note this is a small m, and the options are given here: 0.0354, 0.0177,
0.177 and 1.770.
So here is a question that was asked in the year 2003, and let me read this question for you. In Haber process, 30 liters of dihydrogen and 30 liters of dinitrogen were taken for reaction which yielded only 50% of the expected product. What will be the composition of the gaseous mixture under the aforesaid conditions in it? And then we have the four options. You can go through this question and try to answer this. But let me tell you one thing, why I chose this question. This question tells you two things about the exams. Firstly, you have to know the equations of some of the processes very well. Secondly, there is a small trick involved in this question, and if you don't read it carefully, you are going to miss it and you are going to answer the question wrongly. So be careful. So let's try and solve this if you have not already done so. So the Haber process reaction is N2 plus 3H2, which gives 2NH3. Now, so we have one volume of nitrogen reacting with 3 volumes of hydrogen to give 2 volumes of ammonia. Now in the process we have 30 liters of dihydrogen and 30 liters of dinitrogen reacting with each other. Whenever you pick up this type of questions, you have to know the reactant with highest coefficient and you have to know that that is the limiting reagent. And in order to do these type of sums, you have to pick that up. So here we have 30 liters of dihydrogen reacting with 30 liters of dinitrogen. So we can write 30 liters as 3 into 10, and therefore this is 3 volumes and this is 1 volume. So we have 10 liters here and we have 30 liters here and we have 20 liters of ammonia that is formed. So we have 10 liters of nitrogen reacting with 30 liters of hydrogen to give 20 liters of ammonia, which means that if the process had gone exactly as planned, then it would have been something like this. But what it says, 50% of the expected product was formed, which means that only 50% of ammonia was formed, which means only 10 liters of ammonia was formed. Now this means that we have 2 into 5 liters of ammonia, 3 into 5 liters of hydrogen, and 1 into 5 liters of nitrogen. So in our answer we will be having 10 liters of ammonia, 15 liters of hydrogen have reacted, 15 liters of hydrogen will still remain, so 15 liters of hydrogen, and we will be having 25 liters of nitrogen left. So this is the answer, and this is answer is written here: 10 liters of ammonia, 25 liters of nitrogen, and 15 liters of hydrogen. So this is the correct question. So I hope you have got this. If you have any problems, you can always write in the comments section.
Now I would like you to solve this question that was asked in NEET 2019. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process is A10, B20, C30 and D40. Next we have a question on dimensional analysis. Planck's constant h, speed of light in vacuum c, and Newton's gravitational fundamental g are 3 fundamental constants. Which of the following combinations of these has a dimension of length? And we have been given the 4 options. Now I will help you out with this question. Now Planck's constant h has the dimension of ml square t to the power minus 1 and the SI unit is joule second. Now the speed of light in vacuum has the dimension of LT to the power minus 1 and the SI unit is meter per second. The gravitational constant G has the dimension of L cube T to the power minus 2 m to the power minus 1 and the SI unit is Newton meter square per kg square. So you might be thinking, why am I writing the units of the constants as well? This is nothing but to make sure that if you forget, let me make it clear, if you forget the dimension of any of the constants or anything as a matter of fact, then you can easily derive it if you just know the units. Now, I hope that you know the difference between units and dimensions. For example, in Planck's constant h, the unit is joule second, which is nothing but energy into time. Energy can further be broken up into force into distance traveled. Force can again be written as mass into acceleration, that is m into L into t to the power minus 2 into distance travel, that is L into the second, the dimension of time is t. So we now have ml square t to the power minus 1. So we now have ml square t to the power minus 1. So we can easily see that we can derive the dimensions if we somehow know the units only. Now let me write it down for you. The units: h is ml square t to the power minus 1, g is L cube t to the power minus 2 m to the power minus 1. You can easily derive it. C is L t to the power minus 1. Now if you see, or if you just look at these three constants or the dimensions of this constant, we can see that h and g will have to multiply. And why is that so? Because in the final combination we need only the dimension of length, we don't need the dimension of mass. And if we multiply h and g, the mass and mass just cancel out. So we can easily say that the last two, that is the C and D option, cancel out, and A and B option are the ones that we need to look into. So if you multiply h into g, so let's see what happens. It becomes L to the power 5 into t to the power minus 3. Now if you look closely, then the first option is the option that we are looking for. Why? Because root over hg will have the dimension of L t to the power 5 by 2 t to the power minus 3 by 2, and the dimension of vacuum speed is L t to the power minus 1 whole to the power 3 by 2, and if you just calculate, we will have L as the final dimension. So A is our correct option.
If you have enjoyed watching the video, please like, share and subscribe to our channel and log on to dreamsmadeeasy.wordpress.com. Thank you.